In this video, I'm going to talk about the radius and interval of convergence. And what I'm going to be doing in this video is really over 2 days of class in my classroom. So it's going to be kind of a long video. You can fast forward to see which examples you need to watch. So we've kind of talked a lot about this already in my classroom, but the radius of convergence of a power series is the distance from the center for which the series will converge, so that our approximation is going to equal what the actual series is from our center, the distance. And then the interval is the range of x values within the series that the series will converge. And our whole goal today is to be finding this interval of convergence. Okay, so our first example. Use the ratio test. That's what we use to find our radius of convergence. So we find the limit as n goes to infinity of the absolute value of n plus 1 x to the n plus 1 all over 10 to the n plus 1 times by the reciprocal of our thing. And okay, so let's actually look at this. I'm going to look at this a little bit differently than I have in the past. I think I tend to overthink these, I'm not going to lie. Okay, so the 10 to the n over 10 to the n plus 1 is going to simplify, and I'm going to be left with a 10 on the bottom. The x to the n plus 1 over x to the n, I'm going to be left with an x on top. And then I'm left with, actually I'm going to do a little bit of erasing here. And then I am left with n plus 1 over n. I'm going to put a little parenthesis around that just to be mathematically correct. Now I'm taking the limit as n goes to infinity. As n goes to infinity. So as n goes to infinity, this goes to 1. So what am I left with? I'm left with x over 10. Now remember that for our interval of convergence when we're using the ratio test, x over 10, what you get, your limit has to be less than 1. So really that's like saying negative 1 less than x over 10 less than 1. So our interval is technically from negative 10 to 10, so our center is 0, so therefore the radius is 10. Okay, our next example. Determine the radius and interval of convergence for the series. Now I just want you to think about this real quick. What type of series is this? If you're in my classroom, I always tell you guys to look out for a certain type of series. This series is a geometric. So what do we know about a geometric series? The ratio has to range from negative 1 to 1. So technically here, our radius is equal to 1. Our center, remember if we turn that to x minus a, is negative 5. Let's talk about the interval of convergence. I subtract 5 from both sides. And if you think about it, the average between, or the number that stands between negative 4 and negative 6 is negative 5 with a radius of 1. So be on the lookout for those geometric, okay? And I always tell my students that. Now, a much more complicated example. It's right in this color. Okay, so determine the radius and interval of convergence here. So again, Unless it's geometric, we use our ratio test. Okay, so now it's a matter of simplifying this. Okay, what I'm going to do is I'm going to simplify the 4 and the 4 to the n. I am left with a 4 in the bottom. I am left with an x to the n plus 1 over x to the n. I'm left with an x there. So now the rest of that stuff is n plus 1 times the quantity n squared plus 1 all over n plus 1 all squared plus 1 times by n. Now this piece here, as I go to infinity, I would have n cubed on top, n cubed on the bottom. That is going to 1. So my limit as n goes to infinity is x over 4. Now remember that we want x over 4 to be less than 1. So our interval of convergence is that. Now the radius is from our center, which is 0, to one of the endpoints, which is 4. Now the key thing is once you've found this interval, you need to check in this beginning, when I plug in -4 and 4 into this series, I need to see if it converges at the endpoint. So I need to make sure I check the endpoints. Meaning that when I plug in x equals -4 into my series, that simplifies to same exponent on the -4 and the 4 to a -1 to the n over n squared plus 1. Now look at this and notice it's an alternating series. When you see this -1, remember, go back to that alternating series test. The alternating series test, check in your head, each term gets smaller. That's true. Now you have to state then that the limit as n goes to infinity of n over n squared plus 1 equals 0. So this converges by the alternating, I spelled alternating wrong, that's an L, alternating series test. So what that means is I go back here and I include -4 in. Now checking the other endpoint, checking x equals 4. I plug 4 into my series. 4 to the n's cancel, and I end up with this. Now, we have to figure out if this converges or diverges. So it's all of those tests that we have. So let's compare this to one over n, because that's what that would simplify to. And so I need to figure out which one's bigger. And honestly, if you want to plug in, I'm looking at this now, and I'm noticing that I have a 0 here. Plug in a few numbers. Obviously, I can't plug in 0, so I might have to plug in 1, and 2, and 3, and 4 to figure out which one's bigger. As you get bigger and bigger and bigger, and it works out that n over n squared plus 1 is bigger. So therefore, since diverges by the p series test, must also diverge. So I don't include that endpoint. Woo. And again, I was looking at this and I just noticed something, that if I plug in 0 here, I'm going to get 0 in the bottom. But I wonder if I change this to 1 and 2 and 3 and 4, that this series, that this one here would be bigger, because even that denominator is going to be something that's bigger. Okay, the next example, I'm going to skip a few examples, because if I do all the examples that I intend to do if you were in my class, this would be, I was just looking at the time, this would be a really long video. So I'm going to skip down to this example, because I think this is a pretty good example. I was just seeing if I missed anything. Okay, so now here for this one. So radius and interval of convergence. So we start with our ratio test. Set up my ratio test, and then I simplify my ratio test. I have an x minus 2 on the top. The 3's cancel. I have an n over an n plus 1. So this goes to 1. I don't know why I'm rewriting that. So my limit, therefore, equals x minus 2. So remember that negative 1 less than x minus 2 less than 1. Add 2 to both sides. We don't get 2 Marnell there. You're thinking of the 2. And for some reason you're messing up and you can't do math. You get 1. Now again we test the endpoints. So again, remember when I'm testing the endpoints, I'm plugging this 1 back in for x and trying to come to some conclusion in my series. So when I plug in 1, I get 1 minus 2 to the n over 3n. and this ends up being a negative 1 to the n over 3 to the n. Notice how you have that negative 1. I actually think this is poor that this is n equals 0. I bet you I wonder if this should be an n equals 1. I'm going to look at my notes. I'm not going to redo the video, but I'm guessing my hypothesis is that should be a 1 there. And I will check in on that in my notes. Okay, so because 0 would be undefined. Anyway, I digress. So if these are actually 1s here, so we have this alternating series here, and then I know that each term gets smaller and smaller and smaller, and I know the limit as n goes to infinity of 1 over 3 to the n is equal to 0. So therefore this converges by the alternating series test. Now, that means that I am equal to, when I tested 1, so I'm equal to 1. Now, we test the other endpoint. Test x equals 3. I'm going to guess it's 1 for my n, because that wouldn't make sense. When I plug in 3, I get 1. So now we have to look at this series. Does this series converge or diverge? This diverges by the p series test. So this is my interval of convergence. It also says on here to find the radius. Find the radius. My center is 2. So therefore my radius in this case is 1. And I also can get that from here. Again, I jumped ahead to another example. I'm going to call these next two examples kind of some special examples. So I take my limit as n goes to infinity of n plus 1 factorial all over, times by x to the n plus 1 all over n factorial times by x to the n. Simplifying that, remember that n plus 1 factorial reduces to n times by, n plus 1. Because n plus 1, and then I would reduce by 1, that would get me n, really n factorial. So then I reduce x to the n plus 1, I get x. So as I go to infinity here, I have the absolute value of x times by infinity. So if you ever get an example like this, that means it converges just at x equals 0, because that's the only time that I'm going to have a limit that is less than 1. Okay, if I were to plug in 0 there. So it only converges at x equals 0. Okay, and the last example, I'm calling these kind of the special case examples. I do 2 more examples, 3 more examples. If you were sitting in my class, I might have the students do it to see what they come up with and talk about it in groups, something like that. Okay, negative 1 to the n plus 1. So I'm going through my my ratio test. And I just keep looking at my notes because I want to make sure I'm writing this correctly. I don't know why. I don't have a lot of confidence in myself. I don't know if you heard that chime, but somebody just emailed me. Okay, so let's look at this. So the -1 is going to cancel. I'm just going to be left with a -1. The x to the 2n over 2n, that's just going to leave me with an x squared. Now, understanding what's happening with this, I'm going to have 2n. I'm going to subtract. So my first term on the top for that factorial would be 2n. And then you reduce by 1, so I'd have 2n minus 1. And then I would have 2n minus 2, and so on. On the bottom, we have 2n plus 2 2n plus 1, 2 to the n, because I keep subtracting 1, and then I would have what I basically have on the top. So what this simplifies to here is 2n plus 2 times 2n plus 1. Now the limit as n goes to infinity of this thing is equal to n squared. I'm sorry, the absolute value of x squared times by the limit as n goes to infinity of 1 over 2n plus 2 times by 2n plus 1. Hopefully that's not too small for you guys. This is going to go to 0, so I have x squared times 0. Well, that's always going to be less than 1, so this converges for all x. Okay, and those are my two special cases. Hopefully that teaches you a little bit about interval and radius of convergence.